getting a little bit more into probability tonight. So probability of dependent events. And I think example 1 does a good job of kind of explaining what a dependent event is. Kind of. If a spinner is spun twice, are the events independent or not independent? Justify our answer. So in other words, if we spin this spinner and it lands on a number and then we spin it again, does the second event have anything to do with the first? Does the second spin, is it affected at all by the first? Well, when we spin it the first time, it can land on 1, 2, 3, or 4. And when we spin it the second time, it could still land on 1, 2, 3, or 4. So what we would say is that these are independent events. And the reason I know that it's independent is that whatever happens on the first spin has no effect on the outcome of the second. So if I wanted to find the probability that I spin the number 3 twice in a row, well, there's 1 3 out of 4 numbers. So the probability that it hits 3 the first time is 1 out of 4. And the probability that it hits 3 the second time is 1 out of 4. So we would just multiply those fractions, and we'd get the probability that we get 3 twice in a row. It'd be 1 out of every 16 times. I'll get 3 twice in a row. Okay. But we're dealing with dependent events today. So here we go. We got 4 different cards labeled A, B, C, and D. And they're face down on a table with the order all kind of scrambled up. As a card is turned over, it is left letter side up. So we're going to flip it over, and then we're going to keep it up so that we know where it is. We're going to find these probabilities. What's the probability of turning over the A card first? Well, there's 4 cards we can choose from. Only one of them is an A. So that's real easy. Okay, the probability of turning over the A first is 1/4. Now, what's the probability of turning over the A, leaving it face up, and then turning the B? Okay, well, a little bit of work to do this one. Okay, the probability of turning over the A is 1/4. And then we're going to leave it face up. So we got 3 cards face down. What's the probability that we pick the B next? Well, only one of those cards is the B, and there's only 3 cards left. So what we do is we multiply those 2 probabilities. Now, these are dependent events because you can see the 4 goes down to a 3. So the probability is changing because there's only 3 cards left. We've narrowed the probability that we're going to pick that B. We've made it more likely as opposed to turning the cards back down after each time we pick one. Then it would still be 1/4 times 1/4, which would be 1/16. So what's the probability that we turn over the A, leave it face up, turn over the B, leave it face up, and then turn over the C? Look how this goes down. Probability of turning over the A is 1 out of 4. The probability of turning over the B would then be 1 out of 3. And the probability of turning over the C would be 1/2. So the probability of flipping over cards A, then B, then C in exactly that order would be 1/4 times 1/3 times 1/2. Because remember, with the C, 2 of the cards are already face up, the A and the B. There's only 2 cards left face down. We got a 1 out of 2 chance at that point of picking up the C. And then lastly, what's the probability that we turn over the A, the B, the C, and then the D? Okay. Well, A is 1/4, and we leave it face up. We got a 1 out of 3 chance of getting the B. We got a 1 out of 2 chance of getting the C. The only card left is the D, so we got a 100% chance that we're going to get it. So it doesn't really affect it. It's still 1 out of 24 because we know that D is next. If we had 5 cards, that would change everything. The 4 letter cards in example B are face down on the table. Okay, Michelle's going to turn over one card, find that it is an A. If she turns over the remaining cards one at a time, what's the probability that she turns them over in alphabetical order? So she's already found the A. So we want to know the probability she gets B, then C, then D. Probability she gets B is 1 out of 3. Remember, she found the A. She left it up. Now she's trying to find the B. So it's a 1 out of 3 chance of finding the B. She found that. She's going to have a 1 out of 2 chance of finding the C. And if she gets lucky enough to find that, she's going to have only one card left. It's going to have to be the D. So she's got a 1 out of 6 chance of returning or of turning the remaining cards over in alphabetical order. That's after she already found the A, because it says here Michelle turns over one card and finds that it is A. Now she's thinking, okay, I wonder what the chance that I find the remaining cards in alphabetical order is. It's 1 out of 6 times if she already knows where the A is. Okay, recall that probabilities of an event and its complement total 1. Okay, so the probability of doing something and the probability of not doing something always add up to 1. You guys kind of know this. We've used that a lot with ratios too. In a bag are 6 marbles. We got 3 red, 2 white, and 1 blue. 3 marbles are drawn one at a time without replacement. That means we're not going to put them back into the bag each time. We're going to take one out and we're going to keep it out. What is the probability of drawing red, then white, then blue? Okay, so these are dependent events because every time we take a marble out and leave it out, we're changing the odds on the next draw, as opposed to if we put it back in the bag and the odds remain the same, or the probability remains the same. So we want to know the probability of drawing a red, a white, and then a blue. So what we're going to do is multiply the probability of each event by each other. So the probability that we draw red on the first draw, there's 3 red marbles in there out of 6 total marbles. Okay. Then we got to do the probability of a white. Well, there's if we actually do draw a red, we're going to have 2 white in there out of only 5 marbles left in the bag. And then the blue, well, there's 1 blue marble in there, but now there's only 4 because we took 2 out. 2 goes into 4 twice, 3 goes into 6 twice, and we've got a probability of 1 out of 20. 1 out of every 20 times that you draw 3 marbles consecutively without replacement, you're going to get a red, then a white, then a blue. That's on average. And that's a probability. It's not fact that it's going to happen like that, but the odds are that 1 out of every 20 times. If you do it 100 times, it should happen 5. If you do it 1,000 times, 50 times, it'll come up red, white, then blue. All right, so what's the probability then of not drawing red, then white, then blue? Well, that's the complement. Probability of not red, then white, then blue should add up to 1 when we add it to the probability of drawing red, then white, then blue. So it's 19 out of 20. 20 out of 20 minus 1 out of 20 is 19 out of 20. Last thing for tonight. Gerry's drawer has 2 black socks and 4 blue socks. If he selects 2 socks without looking, what's the probability they're both black? He's in an all dark room. He's just reaching in at random into his drawer, and what's the chance that I'll actually get 2 black socks? Well, the probability of a black then another black. So he's going to take one out, and then he's going to reach for another one. Well, the probability that the first one's black is 2 out of 6. There's 6 socks in the drawer, and 2 of them are black. If he actually gets lucky enough to draw a black one, there's only going to be 1 black one in there out of the 5 remaining socks. So see how not only did the number of socks in the drawer go down from 6 to 5, but the number of black went down from 2 to 1. We can simplify that 2 out of 6, and we see the probability of him drawing 2 black without looking, without replacement, is 1 out of every 15 times. Definitely encourage you to watch this video again. We're using the probability multiplication rule, and we're learning about dependent events here today. See you tomorrow.